So let's start again. Then, so Dr. Michael Water, the Clovis and the Pre-Clovis archaeological lab called south of the North America ice sheets. Could you start the talk?
Well, thank you for inviting me. This is a great pleasure to be here. And today what I want to do is just briefly discuss Clovis, and because we talk a lot about Clovis, and then we'll move on and we'll talk about the pre-Clovis occupations south of the continental ice sheets of North America. And so let's go ahead and talk about Clovis first. And as we all know, Clovis has been the earliest, highly, widely recognized early archaeological complex in North America. And so let's go ahead and just talk a little bit about Clovis and ask first off, what is Clovis? And I think the best definition is given by Mike Collins. It's just an archaeological complex that's recognized by a very distinctive set of tools and technologies. And Clovis had three basic technologies. First, they had biphase technology, in which they would take fine-grained materials, especially chert, like this Edwards chert from Central Texas. They would work it down bifacially, reducing the width, maintaining the length, and eventually producing Clovis projectile points with their lancelet shape and fluted base. Also, they would be producing as well ovate bifaces. Clovis also had blade technology, in which they prepared specialized cores, primarily kind of large wedge-shaped type cores, sometimes conical cores, to take off large blades. Most of the blades in Clovis were utilized unmodified, either snapped and utilized, or just utilized as you see here. Sometimes they were turned into end scrapers, side scrapers, gravers, and other tools. And Clovis also had osseous technology, in which they would use ivory, bone, and antler to make projectile points like this one from Sheridan Cave here, and then over here bibeveled rods that we have seen in other presentations. So the next question is how old is Clovis? And this has been a topic that I've always been interested in. And I can tell you there are about 11 well-dated Clovis sites. There's 3 scattered over here in the northeast. Most of them range from the northern plains all the way down to the southern plains, one over here in Arizona. And all the dates fall into a very narrow time range, about 300 years, from about 13,050 to 14,750 calendar years before present. So the next question is where do you find Clovis? Clovis is primarily found in what is now presently the United States, the lower 48, and going into northern Mexico. The highest densities of Clovis materials occur east of the Mississippi River, going to the eastern coast here. You have moderate densities of Clovis material occurring all the way from the northern plains to the southern plains. As you get across the Rocky Mountains and into the Intermountain West, you find lower densities of Clovis materials, but still there. Going down into Mexico, you find Clovis as far south almost to the Valley of Mexico. Beyond the Valley of Mexico, you really don't find Clovis material. Clovis is not present in South America, and definitely Clovis technology and Clovis artifacts are not found in Alaska. The next question is, are there any other archaeological complexes in North America or even South America that are contemporaneous with Clovis? And recently, the Western STEM tradition appears to, be occurring basically contemporaneous with Clovis. And at Paisley Caves in Oregon, dug by Dennis Jenkins, he found 3 stemmed points that date between about 12,800 and about 13,000 years ago. And this would be the range here of the Western stem. You get down here into the southern part of South America, and along the Pacific coast, you have Quebrada Santa Julia with dates of 13,000. And in Argentina, there are 3 cave sites that date to 12,900 calendar years before present. At all of these sites, they have a unifacial assemblage, but probably is associated with the fishtail points, which definitely date back to at least 12,800 to 12,850 calendar years BP. The next question is who is Clovis? And we got lucky here in that there's one known Clovis burial, and that was the site, the Anzac child that's been mentioned here several times. It was found up here in Montana. This is an intentional Clovis burial of a male child. The child was about 1 year old. The dates on the skeleton itself are pretty accurate now. It's 12,800 calendar years before present, as are some of the grave goods dating to that time period. The grave goods consisted of over 100 lithic artifacts, including Clovis projectile points and preforms, 15 osseous rods, one of which is shown here, that were broken into multiple pieces, and everything from the lithic artifacts to the osseous artifacts to the child were covered in red ochre. Fortunately, we were able to eventually get permission to do the genomic work on this, and Eska Willerslev's group did this. And what they found doing this was that Anzac is the direct ancestor of all modern Native Americans. The second thing is that Clovis and Native modern Americans are derived from a single source population coming from Asia. And so here's Anzac, as you can see, and this is again a heat map like we saw before. You know, the red colors indicating strong connection, darker colors indicating weaker connections. And you can see that Clovis shows a strong connection with people to the south, and Anzac shows a good connection with people to the north. And then as you can see, as you go to Asia, you get a warm kind of relationship and then no relationship whatsoever. Now, the other thing that Anzac showed us, which was really quite striking, is that it showed that the ancestral Native American population split south of the ice sheets into two groups, a northern branch and a southern branch. Anzac belongs to the southern branch, as you can see by this long connection with people living down to the south. The other thing that this genetic work showed us is that there appears to be a deeper time depth of people in the Americas beyond Clovis. And this has kind of been borne out with additional studies that have been done on additional genomes. And I just want to point out two things here, is that the ancestral Native American population appears to have diverged from ancient Beringians around 21,000 years ago, probably somewhere in Beringia. And all the evidence still continues to point that pretty much south of the continental ice sheets, around 15,700 years ago, the ancestral Native American population, broke into this northern and southern branch. So what does all this archaeological and genetic evidence tell us? This evidence that we have. It indicates that people must have been here in the Americas long before Clovis. Now, there's been a lot of debate about these archaeological sites that predate Clovis, and rightly so in many cases. But the first site to really demonstrate an early occupation of the Americas was the Monteverde site down in Chile, dug by Tom Dillahay, dating to roughly around 14,200 calendar years before present. So the question becomes, what about North America? Where are those early sites? I kind of want to take you to three of these localities that I've been involved with and just kind of show you what they look like and what kind of artifacts we have there and the evidence that we have. And then I'll kind of summarize and show you where some of the other localities are situated. The first one I want to take you to is the Page Ladson site in Florida. And Florida is located here, pretty typical over here on the southeastern part of the United States. And the site itself lies submerged about 30 feet below the surface of the water, right along the Osceola River. And believe it or not, right below the water, the calm water here, is the Page Ladson site, 30 feet down. Now, it's in a sinkhole. And for those who don't know what sinkholes are, here's a typical sinkhole. This is a small one. This is in Florida. And what happens is this is limestone terrain, so you get dissolution of the limestone, so you get, a sinkhole formed, or you can actually have a cavern where the roof collapses and create that sinkhole. And the Page Ladson sinkhole is enormous. Okay, as you can see here, this is 10 meters right here. So this is the Page Ladson sinkhole right here. And in fact, the Osceola River is just so unique. It's a karstic fluvial system with sinkhole, shallow channel, sinkhole, shallow channel, each containing interesting geological and archaeological records. Well, at any rate, at the Page-Ladson site, there's a 4-meter thick stratigraphic sequence that contains 2 buried archaeological components. And these were first investigated in 1983 to 1997 by Webb and Dunbar. And they excavated the areas shown in yellow. And then Jesse Halligan and myself, we reinvestigated the site in 2012 to 2015. She continues to work there today. And we excavated these areas in red. So what did we find? Okay, this is an interesting site. I want to point out today we're very close to the coast, but at the time the site was initially occupied, this would have been an inland site about 150 kilometers from the coast. At the base of the sequence are 2 units. We call them Unit 3, okay? And at this time, which would have been at 14,600 years before present, Page-Ladson would have looked like this. Sea levels were lowered 90 to 100 meters below present-day sea level. With it go the water tables, and so the sinkholes would have been exposed, the Page-Ladson sinkhole. At the bottom of the sinkhole would have been a pond, as shown in this depiction. Around it, mastodons and other animals would come down to drink. There would be mammoth digesta and dung just kind of accumulated around here. There would be colluvium coming in from the sides of the sinkhole, as well as I say, the pond sediment accumulating there. Within this Unit 3, again dating to 14,600 years ago, we found multiple flakes and utilized flakes, as you see here, and most importantly, a bifacial knife. Okay, you can see both sides of it here, and here's the piece right here. This is all made out of local Florida cherts, available close by and in other river systems. In addition to that, we have this, Webb found this, which was a large tusk, mastodon tusk, and right up here were cut marks going across the tusk, around the circumference of the tusk, indicating manipulation by humans. Sea level began to rise, people left the area, the site was inundated, more deposition occurred, and then around the beginning of the Younger Dryas, sea level and rise of the water table ceased, and during this time period, people were able to go out on a spit of land that went out into the sinkhole and utilize that all the way from the Paleo-Indian, later Paleo-Indian periods through the early Archaic record. After that, deposition and rise of the water table continued, inundated that archaeological site. And I want to point out that this site is well controlled in time by over 150 radiocarbon ages. I want to take you to another site, which is really interesting, just on the opposite coast, almost a complete opposite of where Florida is. And I want to take you to Washington State. And at Washington State, I want to take you to the Manus site, okay? And this was a single mastodon that was excavated by an archaeologist by the name of Carl Gustafson, who was at Washington State University. And he excavated there from 1977 to 1979. The site itself was situated in a kettle hole. What a kettle is that's a glacial till plain out there that you can see. There was a chunk of ice that was there. The ice melted and created this pond. At the bottom of the pond were the remains of a single mastodon. The left side was still largely articulated. The right side had been pretty much butchered, and the remains of the mastodon were moved up slope. What happened after this, by the way, I should mention that these are right at the bottom of the kettle pond, sitting right on the glacial till deposits. These were then covered up by colluvial deposits, pond deposits, and including volcanic ash and later on in time. And it was estimated by Gustafson that this mastodon dated to roughly around 14,000 years ago. The interesting item that was found at this site was this one rib right here. and this one rib had this funny protrusion sticking out of it, this bone sticking out of it. And Carl Gustafson interpreted this to be a bone projectile point. Well, he didn't get a lot of traction on this, and so we did a reanalysis and published on this in 2011, and we did some more work on it. We found out that it was the 14th rib on the right side, so definitely it could have been, a shot for sure, but it had to go through about 20 centimeters worth of hide and tissue. We reconfirmed the age by dating the rib itself and other materials to 13,900 calendar years BP. We did DNA analysis on the specimen itself. Turns out it was made out of mastodon bone. And we also did a whole series of CT scans and 3D reconstructions of what this looked like. This would be the skin of the rib, and here you go with the point sticking into it. And again, there was some criticism of this site. So what we decided to do was do a new CT scan. And so we very carefully, digitally reconstructed every bone fragment that happened to be within the rib of this mastodon. All in all, there were 24 fragments. We were able slowly but surely to reconstruct every CT slice, which is about the thickness of a piece of paper, and then create these 3D models. We printed the 3D models of each piece, refitted almost all of them except for one or two, and it created this. It created an object that was fairly broad across here, and then if you turn it, it has a plano-convex cross-section coming to sharp points on either end, and you can see how it begins to taper as you go upwards. And looking at this, if you look at this right here and you think, okay, this is just a natural bone, there is no bone of this size, shape, or morphology anywhere in the skeleton of a mastodon. So it must have come from an external source. The only external sources would be a bone projectile point. And again, what helps us realize that this is a bone projectile point is that we have a plano-convex cross-section tapering to sharp lateral edges. We can actually see on the reconstructions, we can actually see the striations made while shaping this. It broadly tapers towards the end. And one of the things that you see here, we reconstructed the pieces that are missing here. It looked like when it struck, it actually burinated on both sides and then broke in the back, which is typical of projectile points hitting something hard. Another thing, looking at this is made of thick cortical bone. Looking at it, we could identify the osteon structure within the bone. The only place where you get osteon structures like that would be in cortical bone that comes from a mastodon leg. So sometime around almost 14,000 years ago, someone shaped a projectile point out of bone that looks very much like a lithic projectile point and used it to try to hunt the Manus mastodon. So lastly, let me go ahead and take you to the Debrielle Friedkin site in Texas. And again, so we're halfway in between now. So here's Texas here shown in red. And we've been investigating the site off and on since 2006. We've excavated over 100 square meters of the site. And the site is located right adjacent to Buttermilk Creek. This is it right here, spring-fed pond. And it's out here on the high floodplain is where we've done most of our excavations. What we found at this site is over 100 diagnostic artifacts in stratigraphic order going from the late prehistoric through late archaic, middle archaic, early archaic, late Paleo-Indian, Folsom, going into Clovis. And then as we continue to dig downwards for the next 15 to 20 centimeters, we continue to find artifacts that we eventually define as the Buttermilk Creek complex. Below this, eventually artifacts ceased to be present within the deposits, and so nobody was home at that time. Unfortunately, in Central Texas, there's not good preservation of carbon, so we turned to the luminescence dating technique. We did 78 OSL ages at the site. We primarily did this in 4 stratigraphic columns so we could correlate. And what we found is that the dates lined up quite nicely with the known age of diagnostics for the late prehistoric, early archaic, the late Paleo-Indian, 9,000 to 11,000, Folsom to Clovis, 12 to 13,000, and 25 ages for the Buttermilk Creek Complex, which gave us a minimum age model of about 13,500 to 15,500 years BP. And again, no artifacts down here in these deposits, which dated between 18 and 32,000 years. What did we find? We found 100,000 artifacts in these deposits, most of it debitage and flakes, but we did find bifaces such as this preform, larger bifaces probably used as shopping tools. We had discoidal cores with multiple platforms and flakes that come off discoidal cores. We found a lot of expedient tools such as spoke shaves, gravers, side scrapers here, even bifacially worked flakes. We found ground hematites, such as this piece, and we also found blades and blade segments. And then we found a lot of radially broken tools where it looked like they were snap fracturing, they were snapping flakes, and they even taking bifaces and smashing bifaces to create these kind of stout chisel-like edges that could be used almost like pseudo-burins. We've done a lot of use wear analysis on these, and we can see polishes and striations, which indicated that they were used on probably bone, antler, ivory, and hard materials like that, indicating that they had an osseous technology. Okay, what did we find in the older deposits in terms of projectile points? We found stemmed projectile points in the deposits dating between 13,500 and 15,500 years BP. Here's this one in situ. This is our complete specimen here. You can see it has a stemmed base, and here's the lancelet form, larger stemmed base. We've got 3 midsections, another midsection, and then several tip fragments here. I should point out that these are beveled, during the flaking process, which is something distinct to all of the pieces here. Above this, but still below the Clovis horizon, we found a very odd projectile point. It kind of had a triangular lancelet shape to it. It had some little basal end thinning to it, but it was very poorly made, as you can see. And again, you can see it's been resharpened within the half, and again, beveled would be the characteristic of the edge during the resharpening itself. What's really nice is if you go just upstream of the Friedkin site by maybe a quarter of a mile is the Galt site, and it was excavated and primarily excavated by Mike Collins. And he's been excavating an area called Area 51 for a number of years. And at Area 51, he found the same sequence of late prehistoric, late archaic, middle early archaic, late Paleo-Indian Clovis, and then going down into what he calls older than Clovis material, with bifaces, blades, tools, and stemmed projectile point fragments, base fragments down here. So it's kind of nice. I like to always point this out because we had 2 teams, 2 different archaeologists, 2 different geologists, different people doing the dating, different people doing other things at the site, and we find the same identical things at both these localities along Buttermilk Creek. So to answer that question, are there pre-13,000-year-old sites in North America? And I have to say, yes, there are. They're widespread. They have biface, blade, and osseous technologies. I first took you, second, I took you to the Manus site here in Washington State. Wally's Beach has been mentioned. This is where we have 6 horse kills and 1 camel kill. No projectile points, unfortunately, associated with them, dated 13,300 years ago, just mainly core tools and flakes. Paisley Caves, human coprolites of 14,100 years ago with some artifacts. 2 forgotten sites which have excellent context and dating are the Schaefer site in Wisconsin and the Hebier site in Wisconsin. One dating to 14,800, the other one to 14,500 cal wire BP with bifaces associated. Took you to Page Latson, Debrel, Friedkin, and Galt, and we'll soon hear about Cooper's Ferry. And of course, to the south, we have Monteverde. So all of this, I think, tells us that what we need to do is we need to come up with a new model for the peopling of the Americas. And I think it's beginning to emerge, and Ben, kind of talked about this as well. And that we're seeing the genetic evidence nicely overlapping with the archaeological evidence now. So that split between the northern branches and the southern branches occurred somewhere between about 17,500 and about 14,600 years ago. You look at the archaeological evidence that we have Galt and Friedkin, we've got the Heber site, you've got Cooper's Ferry, which we'll hear about soon, Schaefer's site, going up here into Page Latson, of course up in here we got Paisley Caves, we got a record with Manus, and then finally up at the top we have up in here Wally's Beach. You go down to South America, you've got Huaca Prieta, and you also have the Monteverde site, as you'd expect, a little bit later occupation or coming into South America at that time. One of the things I want to just point out is then roughly probably around 13,000 years is when you start seeing these regional complexes showing across North and South America. So it's very, very gratifying seeing, the genetic record begin to mesh quite nicely with the empirical archaeological record out there, which they should do. Now, there's always a lot of challenges that suggest that there's even older occupations south of the continental ice sheets. And the most recent one that we've heard about are the human footprints and trackways in multiple stratigraphic layers found around Lake Otero in New Mexico, dated roughly to a maximum of about 23,000 to 21,000 years ago. And this evidence is very interesting and may indicate that people were in the Americas by 23,000 years ago. But if that is the case, then we have to kind of rethink, either, were people here before that split took place? And I think Ben pointed out that that was even a possibility. The other way to look at this is on the flip side is that, at that particular site, there's excellent stratigraphy and good evidence for humans. But the real question comes down to whether those 23,000 year dates are really reflecting the true age of the footprints. And they appear to be dating hydrophytes known as rupia. And it was shown in a recent article published in Quaternary Research that rupia from the same basin dated about 6,000 years older than what it should. There's another lake that shows this, and other hydrophytes show this as well. But it always seems like the maximum offset is about 6,000 years. And I want to point out something that was done back in the 1950s. There was a real famous and well-known geochemist. His name was Wally Broker. And Wally wrote a very interesting article in which he said the maximum offset that any reservoir can have, carbon reservoir can have, depending on the bedrock that it's going through and excluding any kind of contamination from volcanic eruptions or something like this, is the equivalent of one half-life, one radiocarbon half-life. The Cambridge half-life is roughly what? It's almost 5,800 years, radiocarbon years. So I'm not surprised that they're getting numbers of 6,000, and that might indicate that that is the maximum offset that these dates could be. If that's true, then what we're looking at is we're looking at, again, corroborative evidence with the youngest footprints being Clovis going all the way down to 15 or 16,000 years ago. So with that thought, I'll leave you there, and I see that my time is almost up. But I thank you very much for listening, and I think it's just a grand time to be, looking at this problem with all the new tools that we have to do, all the great discoveries that are being made, and I look forward to hearing more about the footprints. Thank you.
Thank you so much, Dr. Walters.
I guess I have 1 minute, so I'll say one other thing. I'd just like to say that the ice-free corridor, I got 54 seconds, the ice-free corridor, the oldest evidence that we have for the opening of the ice-free corridor would be around 13,500 years ago. There was a recent article published in PNAS about this. There's been a terrific amount of beryllium-10 dating being done. It looks like the ice-free corridor opened up in a zipper-like effect, opening up early on to the south, opening up early to the north, opening last in the middle. It was the first animals that came through were the bison around 13,000 years ago, shown by the genetic evidence. And in addition to that, Lake Agassiz would drain through the ice-free corridor, and that really didn't begin based on geological evidence from the McKenzie Delta region where it was draining out until about 13,000 years ago. But all the evidence points to, however, a really early opening of the of the coastal route, again with more beryllium-10 dating being done, showing more and more and more areas are without ice along the Pacific coast. So, finish 12 seconds.
Thank you so much, Dr. Waters. Okay, so next speakers, Dr. Davis, Roland Davis, exploring cultural connections between the Pleistocene people of Japan and North America. Please start.
Thank you. I'm Lauren Davis, and I'd like to thank the symposium organizers first for inviting me to this meeting here in beautiful Kyoto. I'm very honored to be included in this group of interesting thinkers. And today I'm going to discuss some ideas about why and how we might explore the archaeological connections between the Pleistocene peoples of Japan and North America. And my presentation will provide you with an introduction to my archaeological research so that you might better understand how I came to be interested in learning more about the Paleolithic archaeology of Northeast Asia, and in particular, the Japanese islands. So we've already heard today that paleogenetic records show us that the Americas were initially peopled during the late Pleistocene by human populations that originated in Northeast Asia. While the paleogenetic record does not exactly show us where and when key population movements occurred to facilitate this migration, we can also consider technological patterns of late Pleistocene peoples as other important sources of information or evidence. Examination of technological patterns as a signal for the movement of people and ideas offers us a useful avenue of research, particularly considering the relative abundance of late Upper Paleolithic artifacts in Northeast Asian sites compared to the few skeletal specimens available for study. To explore the potential cultural connections between Northeast Asia and the Americas in this way, we must develop new approaches to measuring and comparing the complex design patterns of artifacts like projectile points. Here, I describe the preliminary results of an approach to this problem that I am developing in collaboration with Dr. Masami Asuho, which uses digital three-dimensional scanning and morphometric analysis of well-dated Pleistocene age projectile points from northern Japan and North America. I provide some background to current knowledge about late Pleistocene projectile points traditions in Northeast Asia and the Americas, describe the digital methods of study, and provide two case studies for consideration. This image shows you a map of the geographic regions immediately relevant to the issues of the Pleistocene archaeology of Northeast Asia and the Americas. The study area I will be considering in this presentation includes the ancient landscape of Beringia that connected the northeastern extents of modern-day Russia, Alaska, and Yukon. And we've heard about this already, of course. The study area also includes the Ice Age landscapes of Japan and the Paleo-Sakhalin Hokkaido Kuril region, and the areas of the Americas that were south of the North American continental ice sheets. I will talk about key sites in this region, including the Yano Rhino Horn site in western Beringia, the Ushki Lake site in Kamchatka, late Upper Paleolithic sites in the Paleo-Honshu and the PSHK regions, and sites in the Nenana Valley of interior Alaska. South of the North American ice sheets, I will talk about several sites, including Galt, Friedkin, Meadowcroft, Cactus Hill, Monteverde, and in particular, the Cooper's Ferry site. So first, I will tell you about the work I have done, the research I have done at the Cooper's Ferry site. And the Cooper's Ferry site is located in the western part of the U.S. state of Idaho. And archaeological evidence shows us that humans began to live at this site by about 16,000 years ago and repeatedly occupied the site well into the late Holocene period. During the late Pleistocene, Cooper's Ferry was located in a region that looked very much different than today, close to continental ice, mountain glaciers, and periodic glacial outburst floods. So this image here shows you an example of what the landscape looked like around Cooper's Ferry. Not only do we have the large blue areas in the interior are where glacial outburst floods would have surged across the landscape, but there's a lot of mountain glacier complex areas around the site. The Cooper's Ferry site is higher in elevation than the floods, so we would not have a problem with those events. The Cooper's Ferry site is located in a deep canyon, the Salmon River Canyon, next to the Salmon River. And in this slide, you can see the location near the star on the site. From 2009 to 2018, I directed archaeological excavations at the Cooper's Ferry site. The excavations took place in two block units called Area A and Area B. And this image is available on Google Earth if you know where to look. We were working there one day and a small plane came over the top of us and took a photograph. And so it was very lucky. The archaeological record of Area A includes a 3-meter deep layered sequence that contained artifacts and animal remains created by repeated human occupation that began in a layer of loess, wind-blown glacial dust, that dates to about 16,000 years ago. The image on the left shows the stratigraphy of Area A, along with the positions of fire pits and other kinds of pits related to the human use of the site. The results of the excavation in the early part of Area A was reported in Science magazine by myself and my colleagues in 2019. So what I want to show here, in addition to what I just mentioned, is that we have a fire hearth down here that includes radiocarbon ages that are very close to each other, 12,300 to 12,600 radiocarbon years, which translates to somewhere close to 14,500 or so to 14,700. It ranges through here. We also found artifacts down deeper in these deposits, and we have some radiocarbon dates that get a little older down here, but we also found artifacts deeper. And when we say 16,000 years, what we mean is that statistical estimation of the timing of when people came to first occupy the site is around 16,000. What we lack in Area A is direct radiocarbon dating down here of the artifacts that we find, but we also lack complex artifacts down deep here. We have mostly just flakes, pieces of charcoal, and pieces of bone. So we didn't understand much about the cultural patterns of people early on. Along with my colleagues, I'm working to publish new results in the excavation of Area B. And as you can see in the image at the left, 3-meter deep excavations in Area B revealed additional evidence of early cultural occupation at the site and helps to confirm the early age estimates derived from the Area A excavations. We recovered 3 pit features in the lower Lust deposit that included animal bone fragments that were radiocarbon dated to between about 16,675 to 15,240 calendar years before present. Bayesian analysis of this radiocarbon record indicates that the early occupation of Area B began at around, let's say, 15,800. So this image shows the Oregon State University students working under my direction and with direction of graduate students, very carefully excavating the lower Lust deposits. We found 1, 2, 3 pits that go into the early Lust deposits, and there are many ages associated with each of the different pits. The image at the left shows a map of the artifacts and animal bone fragments that were found in the 3 cultural pits from the bottom of Area B. At right, you can see one of the pit features as it was being excavated. So this slide shows the very careful piece plotting, finding in place and mapping everything that we could find in that lower Lust deposit around the pits. And these numbers, the 73 dash numbers, show us the position of projectile points that we found inside the pit features. And 2 of them were also found outside. 2 of the 3 pits contained 11 projectile points, and 2 other projectile points were found in Lust deposits outside of the pits. Here you can see a stratigraphic view of the pit features, projectile points found inside and outside of them, as well as the radiocarbon dates associated with the pits. So this slide here shows again the 3 pit features. One is behind the other one in this view. This is looking to the north, so it was a little strange to draw it. But here we have the projectile points inside and also outside in the position of radiocarbon ages. This is an erosional boundary here that truncates, cuts off the top of the stratigraphy. So we jump pretty quickly to early Holocene ages. So we're missing some of the record at this part of the site. The projectile points found in and near these Area B pits are shown here at the right. These newly discovered projectile points are thousands of years older than Clovis fluted points, which date to about 13,000 calendar years before present in North America. And these points are also about 2,300 years older than the stemmed points we previously reported in Area A in 2019. So this slide, again, is showing us these different points. What's interesting is they are made on local materials. All of these materials can be found within 20 kilometers of the site. And many of them are broken, many of them are complete. And we also have this one here, this very small one, fits on your thumbnail. Very small. And so, interesting stuff. And when we start to think about these earliest points from Cooper's Ferry, they have weak shoulders and contracting half margins. And these are designs that are also seen in other pre-Clovis aged stemmed point sites, including the Friedkin site, where it dates to 15,500, as I mentioned. So here in this diagram, or this figure, here's the Friedkin point, very similar, I think, kind of hafting style to what we're seeing in some of these. These are projectile points from the Galt site. Here is a very small one that was found below the Clovis horizon at Galt. Now the base is a little different, but again, very small projectile points are not uncommon in these earlier, older than Clovis style things. These are points from the Cactus Hill and the Meadowcroft site on the right-hand side. These points are not necessarily dated that well, but I think that it's interesting to think about them in this context. They're presumably older than Clovis. The timing of it is maybe not as secure. One of the projectile points from Cooper's Ferry also has a similar technological design as early El Hobo lanceolate points that come from sites in South America dating to about 14,800 or so, 14,200 maybe. So here's two examples of El Hobo points. One is from the Taima site in Venezuela here, and this one is from the Monteverde II occupation we've heard about already. So I put an orange box around this one. This one has been resharpened at least once, and you can see here a very small transition from the haft to the blade. So it may have looked more like this perhaps, I'm not sure. But it's at least a very large lancelet made on andesite or basalt. So this slide shows a drawing of the different kinds of projectile point traditions or industries that have been found or inferred to have been present at late Pleistocene age sites in Northeast Asia, Beringia, and the Americas. From left to right, these technological traditions include the blade point industry, the osseous organic point industry, the composite microblade point industry, the stemmed bifacial point industry, the small triangular point industry, and finally, the fluted point industry. This variation in projectile point technology represents different patterns of cultural knowledge that were invented, shared, and moved around the late Pleistocene landscape. To think about the archaeological connections that might be shared between Northeast Asia and the Americas, we need to review the dated archaeological record of projectile points. In the next slides, I will provide a model that illustrates where and when different kinds of projectile point technologies appeared in Northeast Asia. The earliest projectile technology in Beringia comes from the Llano Rhino horn site in northwestern Beringia, which dates to between about 33,000 to 31,000 years ago. The discovery of carved rods made from rhino horn like these shown above have led to interpretations that the site may show part of a projectile weapons system, although how it was designed and functioned is not clear. Similar kinds of bone and ivory rods have been found in younger Clovis and also Western stem tradition sites in North America, where they are assumed to work as shafts that hold stone bifacial projectiles. No bifacial projectile points were found at Llano, however. After 15,000 years ago, microblade technology appears, as we see over here, in the Nenana River Valley of Alaska, which is interpreted to possibly show that the use of composite microblade and bone or antler projectile points like this, shown above. My apologies for how small these look, but the model gets rather large. By about 14,200 years ago, small triangular points appear in eastern Beringian sites, and by about 13,300 years ago, small projectile points made of stone appear in Kamchatka at the Ushki Lake site. So here in the eastern part of Beringia, we have a microblade tradition, small triangular or teardrop point tradition, and also a stemmed point tradition at Ushki. To the south of Beringia, the Pleistocene archaeological record of the Paleosocoline Hokkaido Kuril region shows many different kinds of projectile point traditions. Beginning about 32,000 years ago, Upper Paleolithic peoples were making linear blades with modified base margins, which are interpreted as being projectile points. By 29,000 years ago, an industry based on the manufacture and use of flake tools appears, which may reflect the creation and use of organic projectile points that do not preserve. By 26,000 years ago, microblades appear in PSHK and may signal the use of composite blade and organic projectile systems. Just before 21,000 years ago, people occupying the Okoshirataki site, which is shown here in the black bar, made projectile points, bifacial projectile points with stemmed bases. And this pattern continues on until the end of the Pleistocene. Leaf-shaped and smaller stemmed points of the incipient Jomon pattern appear in Hokkaido by about 14,700 years ago, and smaller stemmed points appear toward the end of the Pleistocene, incipient Jaman to initial Jaman. I want to bring your attention to two important sites in Hokkaido that are part of the stemmed bifacial point industry. Excavations at the Okashiotaki site found an archaeological component containing stemmed bifacial points, larger bifaces, and a prismatic blade technology. This component contains a cultural charcoal layer that dates to between about 21,400 and 19,830 years ago. And this is work that Masami Yasuho is working on himself. So if you have more questions about that, you'll have to ask him. Excavations at the Hotorodai site found another archaeological component containing stem bifacial points, larger bifaces, and prismatic blade technology again. This component contains cultural charcoal that dates between 16,750 to 16,170 years ago. The earliest unequivocal projectile points in the Americas come from sites described earlier and date to, or they appear after about 17,000, probably closer to 16,000 years ago. These earlier points are part of a stemmed and lanceolate point tradition in the Americas that predates fluted lanceolate point technologies, including Clovis, that appear about 13,200 years ago. Considering this projectile point chronology model, I think it's very reasonable to hypothesize that the stemmed bifacial point industry of the late Upper Paleolithic Hokkaido area might be connected somehow to the early stemmed and lanceolate point tradition in the Americas. While future research may lead to the discovery of different projectile point technology that predates what we currently know about the archaeological record of Beringia, the known differences in the timing and technological patterns do not currently indicate the technological precursor to pre-Clovis archaeology in the Americas comes from Beringia. While I do not know yet whether this cultural connection between Hokkaido and North America actually happened, I think it's an idea worth considering with future research. How might we do this? So this slide shows two digital three-dimensional models that were made from photographs Masami Yasuho and I collected during a pre-pandemic research trip to Hokkaido archaeological centers. And there are various methods available for making three-dimensional models of artifacts, including photogrammetry, that is the use of cameras, structured light scanning, laser scanning, and other methods. And these methods are relatively fast, they're non-destructive, and they can provide interesting data sets that support innovative approaches to analysis. Making and sharing these digital models will allow us to more effectively collaborate and can stimulate new kinds of thinking about early Japanese technologies. Working with colleagues, we have developed new computer-based methods for measuring and comparing the shapes of projectile points like these. And these digital models can even be printed for more traditional sharing among colleagues. And I hoped to be able to bring some printed examples, but they didn't arrive in time, and I was worried that they would take them at the airport. But what you see here are two different models showing different views, and the real models, you can simply grab them with a computer mouse and you can move them around and manipulate them. And you can also, as I mentioned, measure them in ways that you cannot do by hand. You can do very complex measurements. I also conducted a study using digital three-dimensional models of projectile points from the Ushki site in Kamchatka, Russia. This project was conducted in collaboration with archaeologist Irina Poktravata, who conducted excavations that led to the discovery of the late Pleistocene age stemmed points seen on the top line here. We were curious to see how geometrically similar the Ushki points might be when compared to late Pleistocene age stemmed points from the Cooper's Ferry site. We also compared the hafting portion of the small stemmed point from the Galt site in Texas. We used a method that combines the digital models and measures the metric differences across their three-dimensional forms to show what parts were similar and to what degree. This slide shows the results of this three-dimensional comparison of the Ushki points to other stemmed points. What we see is the design and form of the Ushki points were very similar to each other within the Ushki site itself. And this is shown at the top of the slide here, where it says Ushki 9. The amount and location of differences in three-dimensional form can be seen by the color, where blue is most similar and generally less than 1 millimeter different, and the red areas show the greatest difference up to more than 3 millimeters. So our analysis showed that the central portion of the blade to haft parts of the points not only at Ushki, but also between Ushki and Cooper's Ferry. The blade margins, these are extremely similar in design in the center, while the shape of the blade margins in areas away from the tip area is what's much more different. Even the haft designs of the Galt point were extremely similar to the stemmed hafts on the Ushki and Cooper's Ferry site. While the overall shape of these points can clearly be seen to be different, there is an internal three-dimensional form that can be found inside the blade and haft aspects of late Pleistocene age stemmed points in Kamchatka and North America. I hypothesize that this may show us that the traditional designs for the creation of a specific ballistic shape may have been shared among human populations moving from Northeast Asia to the Americas. And tracing out the distribution of technological patterns like these may be a productive approach to comparing the archaeology between Northeast Asia and the Americas. So what this is really showing us is that the site at Ushki and also other ones in North America at least share some aspects of design. And you might think that's not that important, but somebody had to design this. Somebody had to invent this. And the question of when that happened and where, to me, is very interesting. And so far, it seems to me the best examples might be in the Japanese islands. So next steps. In this presentation, I've shared information that I think should lead us to consider that some kind of cultural connection existed between the Paleolithic peoples of Japan and the Americas. And to explore this hypothesis, we should make more 3D models of Japanese late Upper Paleolithic artifacts that clearly predate the appearance of projectile points in the Americas. We should also make comparisons of projectile point technologies as they occur across time and space in Northeast Asia and the Americas to see whether we can find cultural transmission networks that were established by the first Americans. This kind of study described here should be carried out in other parts of Northeast Asia, for example, Korea, China, Russia, and the Americas beyond the study areas described here to provide broader perspectives on shared late Pleistocene technological patterns. So one thing I would like to say that's not on the script here is that discussion of comparisons with technologies from the Americas to the Jomon patterns, in my opinion, are rather irrelevant because we're not talking about a time period for the Jomon that is early enough to contribute to the technology of the Americas. And because we don't have any information about the genetics of late Upper Paleolithic peoples of PSHK, I don't think we can say a lot about whether those people are contributing anything at all to the Americas or not. So we'll have to wait to see with that. In the meantime, we can think about culture and how culture is being passed around. I think that's an interesting idea. Thank you very much.
Hi, thank you. Thank you so much, Davis, Dr. Davis. So we have 1 minute 30 seconds. If you have very short comment or this question if you have. Okay.
Thank you.
Thank you so much. So then, next speaker is the Dr. Otis, Daniel Otis. The title is Humans in North America during the last glacial maximum evidence and implication from White Shandon, New Mexico, US, United States. Please start.
Thank you. Let me begin by thanking Professors Naoko Matsumoto, Shunwa Honda, and Ben Potter for organizing this excellent symposium and for inviting me to participate. I would also like to thank the Center for Research on the Dynamics of Civilizations for sponsoring it. Before I get to the substance of my presentation, I would also like to acknowledge my colleagues in this work, particularly David Bustos, Matthew Bennett, Jeff Pagati, Kathleen Springer, and Tommy Urban. And I acknowledge that the work I will be discussing was conducted on lands that are ancestral to a number of Native American groups, and that I will be discussing their history and their heritage. Finally, I note that I'm employed by the National Park Service in the US, but I'm not here as a representative of the US government. I'm speaking as a private citizen, and that's something they require me to disclose to you. So, I'll give you a brief introduction to some of our work at White Sands. And then I'll talk more specifically about an area we call Locality 2, where we have reported evidence for human presence during the last glacial maximum. I'll then move to offer some broader observations about what I think it all means for human dispersal out of North Asia via Beringia into North America. White Sands National Park is located in the Tularosa Basin in the Chihuahuan Desert in southern New Mexico in the southwestern United States. The park's roughly 325 square kilometers preserve remnants of Paleo Lake Otero, a large Pleistocene lake that served as a focal point for human and animal populations. As the name implies, the park also preserves parts of the world's largest gypsum dune system, which is readily visible from space. While the park was established because of the white sand dunes, it is the ancient lake and the evidence for human and animal activity along its shores that are of interest today. Ancient animal tracks were first reported at White Sands during the Dust Bowl era from 1930 to 1936, a period of widespread drought and erosion in the western United States. We are seeing similar erosion at White Sands today. As the ground surface continues to dry out, that erosion continues to expose and ultimately destroy new tracks. Often we find these tracks exposed on surface, and a single trackway can extend and be preserved for kilometers. Such trackways can be challenging to date, and often it is only possible to date them based on what we know of the age of the animals that made them. We assume, for example, that a mammoth or giant ground sloth track does not date to the Holocene because there's no reason to think that those animals remained in the area or remained at all into the Holocene. But even if we can't date such surfaces precisely, they are hugely important because they preserve something we would not otherwise be able to study. And that is the interactions between individuals and between different species. One of the things that makes trackways at White Sands so important is that they preserve evidence of the interaction between individuals, such as an individual carrying a child, setting it down, and then picking it up before resuming her journey. But they also record how different taxa interacted. In 2020, for example, we reported on a double trackway made as part of an out and back journey by a woman carrying a child. In that paper, we showed a giant ground sloth coming across the outbound tracks of the individual and reacting to it, standing up on its hind legs, turning in a circle and changing direction, responding to the presence of a human in a way that we suggest shows awareness of a potential predator. A single mammoth also crossed the tracks of the human, and in contrast to the sloth, the mammoth did not react at all. It didn't pause, it didn't stop, it didn't change direction, it just kept walking, as though it were completely unconcerned with the presence of a human on the landscape. Now, I should add that we know these tracks are more or less contemporaneous because the sloth and the mammoth both stepped on the human's tracks. And then, when the human returned, hours or days later, she stepped on the mammoth's and the sloth's tracks. So we have this series of events that kind of packages this tightly in time. Over the past several years, we've found numerous examples where tracks made by humans and extinct megafauna occur on the same surface, but naturally, we wondered how old they were and whether they might be contemporaneous. Finding examples where the makers were interacting or where their tracks cross-cut each other demonstrated contemporaneity, and it confirmed that we had human tracks dated to the Pleistocene. Not just one track, but lots of them, and not just one trackway, but many trackways at different localities around the park. Here, for example, is a set of human and sloth tracks that we believe was created when humans were harassing or hunting the sloth. We had multiple individuals interacting with an animal that is now extinct. But other than knowing roughly when humans arrived in the region and when sloths or other animals went extinct, we had no way to establish their age. What we needed were buried surfaces that we could date. A little over a year ago, we reported on the results based on fieldwork conducted at a locality with deeply stratified track-bearing sediments located on the east side of the Tularosa Basin. We term this Locality 2. We targeted this area because it is a shoreline of ancient Lake Otero. We knew there were tracks present, and we expected it would be a focal area for both humans and animals. The specific location was chosen because it showed potential to hold buried track-bearing surfaces where we thought we might be able to find organic material that we could date. We approached this work using a combination of area excavation to expose individual tracks and trackways on buried surfaces, and trenching to reveal the stratigraphy of the deposit and the relationships between individual track-bearing surfaces. Ground-penetrating radar helped us decide where to dig and continues to help us to understand what remains buried in the surrounding area where we have not yet excavated. The sediment is gypsum-rich and partially cemented. We cut the trench using power tools and removed sediment in blocks. You can see some of the blocks there in the image. The blocks typically broke on horizontal cleavage planes where the different strata intersected. And these often revealed tracks of multiple taxa. Human tracks were the most abundant and were present from the top to the bottom of the stratigraphic sequence. During fieldwork immediately before the pandemic, we identified 7 stratigraphically distinct track-bearing horizons. So we had tracks on 7 surfaces. However, due to time constraints and the ensuing pandemic, we were unable to reach the bottom of the track-bearing sequence. And we were unable to excavate stratigraphically higher levels by extending the trench further upslope and into the slope. As a result, we were only able to report the results from the middle of the depositional sequence at the locality. And I should add that we did not conduct aerial excavations on many of the surfaces beyond confirming the presence of human tracks in or adjacent to the trench. It was this work that formed the basis for the paper we published last year. In January of this year, we extended the trench to a total of 22 meters in length. Younger strata were exposed higher up along the eastern part of the trench, and older strata were exposed lower down on the west. Older strata also occur beneath the exposed strata on the east, But we didn't expect they would be that deep, and so we made the trench too narrow. So we aren't able to get to the bottom where it is, where the trench itself is particularly deep. The base of the sequence is a dark gray gypsum-rich silt deposited when the water table was higher. We have not excavated below this level, and the nature of the sediment may make it difficult to identify tracks within it, even if they are present. However, tracks are present and abundant in the strata immediately overlying it. The vertical distance from the top of the section on the east to the bottom of the section on the west is approximately 2.3 meters. We have now identified more than 20 track-bearing strata within that deposit. And I should add that human tracks are present throughout the sequence. Locality 2 is part of the former shoreline of Paleo Lake Otero, and the strata reflect fluctuations in lake level over time, with a general trend from wetter to drier. They are comprised of both alluvial and aeolian sediments. Some strata are rich in the seeds of Rupia serosa, a type of ditch grass. We found human and animal tracks pressed into surfaces that were littered with these seeds, and the seeds were often still attached to the delicate stems, suggesting they lay where they grew and fell. In this image, you can see what the seeds look like when they're exposed on the cleavage plane between strata. The other image is a mammoth track, with the texture of the sole of the foot still readily visible. And the close-up on the lower left shows the underlying seed layer displaced by soft sediment deformation. To date, we have recorded mammoth, giant sloth, bison, bear, large cats, large wolves, and I mean large wolves, like dire wolves, and one medium-sized bird at locality 2, along with the humans. We're not seeing smaller herbivores, and this could well be a sampling issue, but I find it curious. One of the important things to keep in mind about tracks like these is that we know they remain in situ. If they moved, they were destroyed, and so they remain in situ. Unlike animal bones or stone tools that may be redeposited through various formation processes, we're wholly confident that these tracks are in a primary depositional context. And we're also confident in our ability to assign most of them to the appropriate taxa. As our sample of tracks made by individual animals continues to grow, we're also learning more about the variability of tracks made by individuals. This in turn will only help us to refine our analyses and also to train artificial intelligence for machine learning. I'd like to turn now to the topic of dating, since I know our assessment of the age has caused a bit of a stir. We did not set out to place humans in North America during the last glacial maximum, or to show that the site contained older evidence for human presence than virtually all of the other known sites in the hemisphere. We simply wanted to know how old the tracks were so that we could situate them within a broader cultural and environmental context. We dated the Rupia seeds because that's what was available. We have not found charcoal or other macrobotanicals other than pollen. The seeds are abundant and well preserved in some strata, and so we were able to collect lots of them from discrete locations within each individual strata. All samples were collected from the trench wall to ensure that we had firm stratigraphic control. Sampling and characterization of the stratigraphy was done by Kathleen Springer and Jeff Pagati of the United States Geological Survey, and they lead our dating efforts on the project. We believe we've evaluated the potential for hard water effects to have caused the seeds to yield dates that are too old. We believe the context from which the seeds were collected, shallow water in which people and animals were walking, precludes the idea that they could be reflecting a hard water effect because they would be at equilibrium with the atmosphere. We dated samples composed of 50 or more seeds from each of several different strata. We found that the dates conformed to their stratigraphic order. With a single exception, dates from the strata yielded statistically similar ages. Dates from the same stratum yielded statistically similar ages. None contradicted the stratigraphic order at 2 sigma confidence level. And so while a handful of papers have raised questions about the dates and suggested that they could be too old, so far there's no actual evidence to indicate that they are in fact too old. What the dates do is challenge some existing models for the movement of people out of Northeast Asia into North America. But as we all know, models themselves are not data. I recognize that there continue to be questions about the age of the site, and in particular, the possibility that hard water has affected the rupia. And I absolutely agree with those who would like to see dating tested and corroborated or refuted using techniques and samples that couldn't be subjected to a hard water effect. That work is currently underway, and while I cannot share the results at this time, I can confirm that we stand by the dates that we've already reported and our conclusion that humans were present in the American Southwest during the last glacial maximum. We returned to locality for a couple of weeks this past January to continue work that was disrupted by the pandemic. We were joined by Carol Ellick, Joe Watkins, and Ed Jolie in this work. Naturally, it will take some time to analyze the additional data that we've collected, and we do have a few surprises in store, but I'll give you a couple of updates here. As I said a few minutes ago, we continued our excavation so that the trench is now about 22 meters in length. It is about 2.3 meters deep, and it includes at least 20 discrete track-bearing surfaces, all of which include humans. We've reported calibrated ages between about 23,000 and 21,000 years ago for the strata that we have dated as of 2021. These strata are from the middle of the depositional sequence and together appear to have been deposited over a period of about 2,000 years. If we consider one generation to be about 20 years, that means we're talking about roughly 100 generations. The presence of human tracks above and below the dated strata confirm that humans were present sometime before 23,000 years ago, and that they continued to be there until sometime after 21,000 years ago. But at this point, we don't have better chronological control than that. Based on that fact, however, it seems likely that humans were there well before 21,000 years ago, and that they were there for more than 2,000 years. We have not demonstrated continuous occupation from the last glacial maximum to Clovis times. I want to be clear on that, so that there's no firm evidence that we have continuity from 23,000 to the present. That said, it does seem more likely than not that the continuous occupation of the region began sometime before 23,000 years ago. So how does all of this relate to the movement of anatomically modern humans out of Eurasia? If humans were in fact present in the southwestern United States before 23,000 years ago, who were they and how might they have arrived? It seems obvious that the discoveries at White Sands also have implications for understanding early human migration into the Americas, including the question of the route or routes by which they arrived. And in the interest of time, I'm not going to rehash that debate because, well, we've touched on it already, and I'm sure you're already familiar with it. If you're not, there are some excellent overviews written by some of the speakers in this symposium. What I will say is this. There has been a great deal of attention given to conditions along the Pacific coast and in the ice-free corridor during the millennia immediately following the last glacial maximum. This has allowed detailed reconstructions of post-LGM glacial history and the suitability of potential routes at different times. However, far less attention has been given to conditions along those routes before and during the last glacial maximum. The discoveries at White Sands amplify the need for additional work in those areas and on those topics, focused on that critical period in the expansion of modern humans. In my view, it is unlikely that humans migrated for the first time from Asia to North America 23,000 years ago and immediately started leaving tracks around glacial Lake Otero. I suspect they were there sometime earlier. How much earlier is unclear. Because small populations have very low archaeological visibility, it is conceivable that they were widespread, even if we haven't found them. It's worth noting that if humans occupied the interior route prior to the last glacial maximum, subsequent advance of glaciers during the LGM is likely to have buried or destroyed evidence from that area prior to about 23,000 years ago. And I should add that I'm using that 23,000 date because that's when the paleobiologists have shown that bison were interacting between eastern Beringia and mid-continental North America. The same would be true along the coastal route, had that been available. And for this reason, I don't expect that there will be well-preserved evidence of humans along either the ice-free corridor or the Pacific coast from before or during the LGM. That said, the evidence may or may not have been there, and we need to be careful not to confuse the absence of evidence with evidence of absence. We have no direct evidence for how humans first reached mid-continental North America. Instead, whether interpreting archaeological or genetic data, we are left to rely on circumstantial evidence, much of which comes down to whether we find particular scenarios to account for patterns in the data to be plausible. We build models to account for those patterns, and we use data to test those models. But as I said a minute ago, the models are not data. And when the models no longer explain the data, we need new ones. Each of us knows this, but there is a worrisome tendency when employing models drawn from other fields to confuse the underlying facts with the models that have been developed to explain them. The age and location of the discoveries at White Sands challenge us to re-examine models for the peopling of the Americas and the assumptions that underpin them. They also highlight the need to distinguish facts from the models that we've built from them. Let me turn briefly to the topic of genetics and the models that bear on this topic for this symposium. I want to be clear that I am not a geneticist, and I would defer to several of my colleagues here on this matter. And there's currently no available genetic data from White Sands that might contribute to this discussion. We simply haven't found any. And in fact, the oldest document genomes anywhere in the Americas postdate the human arrival at White Sands by more than 10,000 years. There are also very, very few genomes from anywhere in pre-contact North America, making it hard to know whether there are in fact extinct lineages that we simply haven't identified. And so I want to pose two questions. First, does the currently available genetic data somehow contradict the idea that humans were present at White Sands during the last glacial maximum? And the answer, of course, is no, it does not. I think there is widespread agreement that if the people at White Sands are as old as we think, they could be unrelated or only distantly related to the indigenous peoples of the Americas. We should remember that the genetic data speak to relationships and the timing of the events that led to those relationships, but they do not contain information about where the events that formed those relationships occurred. We know, for example, that the ancestors of Native Americans were isolated from their Asian relatives for a period of time that has been called the Beringian standstill. What we don't know is where those ancestors were when that period of isolation occurred. And this leads to the second question I would pose about the genetic data. Do the currently available genetic data prove that the people who left tracks along the shores of Lake Otero during the last glacial maximum are not ancestral to some of the modern indigenous peoples of the Americas? Are there scenarios by which they could be? Is it possible that the isolation described in the Beringian isolation model could have occurred south of the ice sheets when the advance of glacial ice severed contacts between a small population in the Americas and their relatives in Asia? Perhaps they were members of what has been termed Population Y, or if it exists, unsampled Population A, or some other yet to be identified lineage. I don't believe it is possible to reconcile all the currently available data from archaeology and human genomics with current models for the peopling of the Americas. And so I suggest we might consider whether there are new models that better account for all of the currently available data. I've attempted to depict one such model here. It is flawed, and I have little doubt that there are others yet to be articulated as well. So how did they get to the southwestern corner of the United States, and what does that mean for the human dispersals from North Eurasia via Beringia into North America? I'm going to go out on a limb here and suggest that confirmation that humans were present in North America during the LGM makes it likely that they came via an interior rather than a coastal route. Whether they then utilized the coast to travel south into or along the southern coast of North America, Central America, or South America is a separate question. Initial arrival via the interior in no way precludes the use of boats to move further south. My rationale for suggesting the interior route is more likely than the coast is really pretty simple, and it's based on the reconstructions of glacial history that have been done in both areas over the past several years. We've known for a while now that the Bering Land Bridge emerged sometime before 30,000 years ago and was dry land until roughly 12,000 years ago. Recent efforts by April Dalton and colleagues to synthesize the available information on glacial history suggest the Laurentide and Cordilleran ice sheets did not converge until 25,000 years ago. And discussions with colleagues in British Columbia suggest it's even more recent than that. As I mentioned a minute ago, Heinzman and colleagues have demonstrated that bison in eastern Beringia and mid-continental North America were interbreeding until about 23,000 years ago. From this, it seems fairly certain that humans could plausibly have walked across the Bering Land Bridge and followed an interior route south between, say, 30,000 and 23,000 years ago. And that they could have done so without ever catching a glimpse of the Pacific Ocean. Indeed, while it is far from conclusive, a couple of recent papers by Lorraine Bourgeon and colleagues on bluefish caves would lend weight to the idea that humans were present during the LGM in interior eastern Beringia. But what about the coastal route? Before I change slides, I want to call your attention to the Pacific coast in the reconstructions done by Dalton and colleagues, which show that much of the Pacific coast of northern North America was under ice by more than 35,000 years ago. As the work of Christine Bachelor and colleagues has shown, beginning around 40,000 years ago, the coast from the Alaska Peninsula south to British Columbia had increasingly extensive ice, and over much of its geography, and well before the last glacial maximum, ice extended to and covered a broad expanse of the coast. This is not to say there were not isolated refugia here and there during the LGM. There may have been. But the most recent constructions suggest that unbroken stretches of glacial ice along the coast extended for hundreds of kilometers, beginning long before the last glacial maximum, and that did not start to thaw until roughly 18,500 years ago, long after people were already at White Sands. Could the ancestors of the people who left the tracks at White Sands during the LGM have arrived by way of the Pacific coast? It's possible. But given the considerable difficulties of traveling along hundreds of kilometers of unbroken ice front, I think it's more likely that small bands of foragers, such as those whose traces were found at Bluefish Caves, gradually arrived by expanding through the interior. The alternative requires not simply that a handful of intrepid paddlers made it past the ice, but that a founding population large enough to be viable for more than 100 generations did so. I believe that scenario to be possible, but highly unlikely. In closing, let me say this. The question of when humans first arrived in the Americas remains unanswered. And because small populations have very low archaeological visibility, it will likely remain unanswered. The history of scientific advancement is built on a foundation of carefully established fact that could not be explained by prevailing models of the day. Rigorously testing the validity of those facts and confirming or refuting them through independent lines of evidence is critical. Based on the actual evidence currently available, I suggest the ages we've reported for the human presence at White Sands are correct, and that it is therefore time to take a hard look at the prevailing models for human dispersal from North Eurasia via Beringia into North America and the assumptions that underlie them. This symposium is an important step in that direction. Thank you for your kind attention.
Thank you so much, Dr. Daniel Aldis. So we want to go to open discussion without a break. Then I would like to turn over the chairmanship to Dr. Ben Potter. Ben, please. Thanks a lot.
So I hope I can read my scribbled notes. I want to thank everybody for really great presentations. Am I audible? Okay. I want to thank everybody for great presentations, and I'm glad to see that there's emerging consensus, but still quite a bit of disagreement as we see models that are developed. One comment I forgot to say at the end of my talk was the old adage, all models are wrong, including mine, but some might be useful. And I think that's maybe how I view models in archaeology and in the genetics. I wonder if it's okay if we want to start with maybe some of the Japanese colleagues that have listened to the talks today before we maybe have more discussions on the Westerner side for thoughts or comments that they have on any of the papers. Yeah, and we do want to open it up later. So please, in the audience, think of questions to ask as well. So Dr. Nagai, I think we had spoke a little bit about the stemmed points.
Oh, yeah, about stem points.
Yeah, did you have
yeah,
any questions for us?
Thank you very much for presentation to Dave's, Lord Dave's. Yes, I have a question. A very interesting presentation. Thank you very much. And I think one question is why do you pay attention to the hafting sickness? Because I think this has the destiny to change functionally. So more different attribute is more it's better to compare to comparison. So why?
Okay, so the question was, why do we pay attention to the haft element? Well, when we were doing the analysis, we looked at the entire projectile point, So we placed landmarks across, so there were many dozens of individual points, and we just simply take one 3D model and we put it inside the other one, and we ask what is the difference in terms of its shape, and the results just simply showed us that there was strong similarity. So I guess the question more is, why do I think it maybe is similar? Because I wasn't making a decision to study one part or another. We were studying everything. So one potential answer could be that there might be standardization of a sort of the kind of weapon system that is associated with those points. So if you wanted to make sure that your points always worked with, let's say, a dart thrower, because it takes so much time to make the organic part, maybe you just make the stone part always the same to make sure that it fits really well. That's one, maybe an idea. So, and that's a very small sample. I was just using it as an example to show the potential. So I don't know if that answers your question.
Yeah, because I'm Japanese free Napa by using experimental archaeological method. So I think the more important attributes is perhaps the Napa's habitus or something flexible pattern. I think so.
There are many, many different things we could look at. You know, I'm familiar with your work with flaking styles, for example. I mean, so getting to the mode of production, how it is made, would be very important also, something to consider. So I think what we were just amazed about is how similar the shape was from two different places. Now, what the connection is, I don't know. But it could be that we just saw the after effects, the result of an idea moving through the landscape. Maybe that's one explanation.
Yes. Okay, that's it. Thank you.
You're welcome.
So any others from,
I know that various bifacial stemmed point tradition have been recognized in North America until now. So, Dr. Lauren Davis, I have one question. Is there a cultural connection between lithic assemblage from the Cooper's Ferry site and other bifacial stemmed point, such as Western stemmed point tradition?
So, is there a connection between Cooper's Ferry and the other ones in North America?
Yes.
That's a very good question, and that's something that I hope that we will be able to answer moving forward. I mean, Dr. Mike Waters has a nice collection to make comparisons with, and then the Galt site nearby has a very extensive collection. We have not gotten to that point yet. We were in discussion about maybe doing three-dimensional scanning before the pandemic, and then the pandemic ruined all of our plans. But I think that would be something important to do. And also, beyond the projectile points, I also pointed out that there are prismatic blades and there are also large bifaces. And that's very important because at other sites, that's one thing that makes these very similar too, is the Galt and Friedkin sites have those technologies also. So very large bifaces, or larger bifaces, and also blade cores. So I think looking at an entire assemblage approach would be very useful, but then looking at individual technologies would be very useful. So yes, I agree with your idea.
Did you compare the outline of reduction sequence of bifacial point production from raw material to final stemmed point in North America?
So speaking only about the Cooper's Ferry site, because I've not done that analysis with other early collections, at Cooper's Ferry we see that projectile points are being made in two ways. One is they're very commonly made by some kind of core, and they're reducing a large linear flake that is being mostly pressure flaked into shape. And then other ones are being reduced from a larger biface to a smaller biface. Later on, the technique seems to be more of the large flake to pressure flake is more important later. But the earliest things I showed you here, it's a strong mix. It's a lot of larger biface to smaller, perhaps, but they're still pretty small, so it's relative. And I say this by looking at the cross section. Some of them are, plano-convex, and some of them are biconvex. So we can see that they're being made on long, maybe blades. And sometimes they retain the original blade feature. So it's a mixture. Unfortunately, we don't have all of the debitage to do refitting, spectacular refitting like in Japan, but no, we don't have that opportunity yet.
Okay, Dr. Azuho?
すいません。これ、日本語で質問した。
May I ask question in Japanese? That's okay.
So please use your interpreter.
Well, let me ask question in Japanese. Why there is difference in models by each researcher? Or I myself looked at the materials on the America, and I agree with the Michael or David. 14,000, 16,000 years ago. Sorry. I will repeat myself. For people in America, the first model for people in America, why are they different among the researchers? That was my initial question.
All might have different answers, but broadly, I think there was similarity. So in my discussion, and I think in Mike's discussion, and also in Lauren's discussion, we're all identifying that period, sometime between 16 and 14,000. And I think broadly is consistent with Martin's representation of the genetic data. So I think, the new find at White Sands obviously is different. It's a different class of find. It's new. It has yet to be integrated, I think, with the genetic models. So we're hashing out some possibilities of how, we could get an early population that seems to be present at a time period when the first Americans have yet to separate fully from East Asians. And so there's uncertainty. So I think broadly we do share some ideas, but the details are different depending on which sites are accepted as the dates are correctly matching unambiguous, unequivocal human activity. And maybe we differ on some sites or slightly differ. But I think that's my sense. Do you guys have other comments?
I think we're all in agreement that there are, say, I don't know, 6 or 8 archaeological sites in North America that are more than 13,500 years old. But we're not in agreement about which ones they are. So each of us has slightly different ideas about what constitutes the most reliable evidence, or the types of analysis that are most compelling. But I think what we're seeing, as Dr. Potter indicated, is even though we approach these things fairly differently, we're all kind of trending in the same direction. I think in the next 5 years or so, you're going to see coalescence around another model that will probably be the dominant model for a decade, and then it too will fall apart as models do.
And I think another point to add on is the differences, I think, largely relate to the lack of evidence. in some cases where we would expect to find it. So each of the models that have been presented, in some way there are gaps, and it's very difficult, as Dan mentioned, to deal with absence of evidence. Lots of things could happen. Same thing with genetic populations, like the Y population. It's an unknown. We really don't know. So I look at it as a very positive thing that we're not entrenched in a single model, but there's an opening of minds to encompass different models that would have different implications. And these we can test with new data. I think that's the approach that I think we all collectively want to proceed in. I hope that answers the question.
Well, as a whole, yes, yes, as a whole, generally, I agree, quite agree, yes. I think there are three. Clovis first model, Clovis recognizing model, and to go back the LGM or retrospective LGM model. So in my opinion, there are represented with three models. What do you think? I want to hear your comment.
In Professor Honda's initial introduction, he had three models presented that was summarized from a paper that my team wrote, and I think broadly correspond. Strict Clovis first, like the idea that it was exactly 13,000 years ago that the first people came. I think we all reject that model here, I think. And then there are two competing models, but they relate to, as Dan mentioned earlier, Native American, Indigenous American genomes. So like the people that now are indigenous peoples of North and South America. It's a different question to say who are the first people, right, that may or may not be ancestors of FAM. So I think from my discussion, my thoughts were only FAM, the first Americans, from the genetic data that we have. And that, I think, is the second model, 16 to 14,000 that we talk. If there's something substantially earlier, I don't know. That would be a different question, potentially. And I think maybe keeping those in mind, that those need not be the same question. The first peoples and the first ancestors of the group that we have throughout the Americas may not be. We don't know. And there could be genetic continuity. I mean, population Y, one thing on the table is that there might have been an earlier population in the Americas when FAM arrived, and that we see that represented in some FAM samples and not others. That's on the table. I think, would you say, Martin, as a live opportunity?
Yeah, I think this is a very important point to make, and a very, very important distinction in terms of speaking of the first people, as you say, that we don't confuse, which I think also historically has been sometimes done by us geneticists, the sort of the ancestors of certain people that are present in a location at a particular time from the actual first people that might have been there. And the amazing thing about ancient DNA is that we can actually for the first time probe these other groups that we didn't see before. Before we only had the record of people, of present day people, and we can only tell something about the ancestors of those. And I think, in terms of these three, maybe two slightly related ones or three models that we're talking about today, I can see that the first two, the strict Clovis first, which is sort of universally rejected here in terms of the timing, and also the slightly earlier Clovis-like people, I think both of these are very much still consistent with the genetic data that we have currently. That I think it's quite clear that present-day Native American populations are largely descended from these people in terms of their ancestry. I think there's no doubt about that from the genetics, and even the slightly earlier sites up to maybe 15,000, 16,000 still would work pretty well in that context of what we know about what happened. Well, we don't know where it happened, but what happened further northeast in terms of the processes that led to the formation of those types of ancestries. If we go back to the sort of during LGM or earlier, I think genetically that would be it would have to be a different group. It could be population-wide, it could be people related to Yana. I mean, they were there at the right place at the right time. And I think from a genetic side, at least, the only two things that we can do or that can happen to sort of prove or disprove that would be we get a direct evidence of DNA from some of these early sites. And I think an important development here is that I would like to bring up, of course, which I have hopes of being the technique that will at least give us a glimpse of that or an insight into that is sort of recent progress in an environmental DNA analysis, where you don't need to have human remains to actually get DNA from humans or other animals. I mean, we have recently shown, we tried that at Chiquita Cave and we couldn't find any human remains, but we could find human DNA. But we did find black bear DNA, for example, that we could actually place in the context of black bear genetic history. So maybe white sands, I don't know to what extent there is any plans, ideas, or possibilities to do environmental DNA. I mean, you have actual human footprints, right? So maybe, like you can think about what kind of samples you would want to have, because it's still, of course, a very big hit and miss kind of scenario of would you find human DNA if you just take DNA from a transect. But if you actually have something like human footprints there, well, the likelihood increases that maybe we would find some human DNA there. I don't know, same, maybe a long shot, but I was thinking about in your presentation, you presented this one bone projectile in the, I don't know, you sequence DNA from it and you showed that it's a mastodon, right? But did you look at human DNA also? I mean, it's a very long shot, obviously, but we're getting to a point where we can start to think about these types of questions with DNA. Can we actually get DNA from the people that handled the material, ancient DNA, and try to use that even on a very, very coarse resolution at the moment to say something about potential people that were dealing with these materials. So that's, I think this is the way that it would move forward. The only way I can see it move forward from a genetics point of view to answer that question about the early people potentially at White Sands. Or we discover some new actual fossil remains somewhere that are sequenced and turn out to be very different. Of course, that would be another way to.
And I just wanted to make a comment off of that with, I think one of the surprising discoveries was this ancient North Siberian group that was present and then later absent. This is helpful for archaeologists to understand that that these kinds of localized extinctions or failed expansions might be very common in the past. And so when we think about Native American history, it's a testament to the resilience and the adaptiveness of these early peoples that they filled both continents and still are thriving today. So it's an important element to keep in mind.
Yeah, actually, also to add to that, I think we have more and more evidence of that also from different regions now. Like I think I briefly mentioned the results from Bachokiro Cave in Europe, which were actually genetically very different to the just 3,000 years later populations at Kostenki and or slightly more years later, but nevertheless in Eastern Europe. So clearly there was one of those, you want to call it failed dispersals or one that we didn't have traces just 3,000-4,000 years later, even in the Upper Paleolithic. There's another paper that came out roughly at the same time from some remains from again from Eastern Europe, from Czech Republic in Zlatý Kun is the place. Also at least 45,000 years old according to the analysis there, which was yet again a completely different genetic lineage that even predated the divergence of Ustishim. So you have in the Upper Paleolithic in Europe all these different early groups that are very different from each other and completely separate from what happens just a couple of thousand years later. So I do think we'll have to start thinking more about these things being very common, even in early human history outside of Africa, that probably a lot of these dead ends, if you want to call them, but dispersals that just then retracted again and didn't leave any descendants. So I think this is something we should absolutely keep in mind.
Any more questions on this side?
I think it's also important to keep in mind the expectations that we bring when we start to look for things and look at things. And one of the things that really strikes me about the Yana site and the Middle Upper Paleolithic material is that compared to later material, particularly in North America, it's very unstandardized. There's a lot of expedient technology there. So, if I say, what does a Clovis toolkit look like? We can all picture a series of formal tools that kind of make it Clovis. But that's much more difficult for the Middle Upper Paleolithic. And one of the implications of that is that it could be present in North America and go largely unrecognized until it's found in a geological context that says, hey, there's something different here, something old here.
So I was going to pose a question to John. I was very interested in sort of the archaeological implications of this idea of a space of design and risk, and then eventually coming to a functional set of solutions, design solutions that are then widespread. I'm wondering if you thought about archaeological sort of ways to get at that sort of attribute. And I'm thinking of Britt Bausman's idea of risk-averse behavior and risk-prone behavior. And I'm wondering do you see anything like this in the records in Northern Eurasia or maybe in Beringia of a period like this? I mean, what do you think in terms of the lithics at least, because that seems to be the best that we've got.
Oh, how's that? No, I don't think so. The problem is that, most of the technology that I'm focused on or was focused on in my talk today is perishable. And we, occasionally we find little bits and pieces of it. But for the most part, we don't know what these artifacts look like as a whole. And so it's, I think it's difficult to know if there are periods in which there is a great deal of innovation and a great deal of exploration of alternative approaches to solving these engineering problems. I think it's just something that isn't visible archaeologically. I mean, you asked specifically with reference to the lithics, and the answer is I don't know. I have no idea whether you would pick up something like that in the lithics.
I think one thing we highlighted that will be relevant tomorrow too is whatever was happening right before the onset of the late Upper Paleolithic, it does seem like almost instantaneously we have a very rigid and strict set of sort of Yubetsu related, Juktai related material culture that seems to be adapted or adopted by lots of different cultures almost instantaneously. That's interesting. And I know people have written about it in the context of maybe high mobility, that it's a way to conserve material perhaps in areas where you don't have readily known raw material sources that you can make larger, more wasteful implements like bifaces. So I think that might be one thing that bridges both the Japanese record and the Beringian record is this reliance. And in that context, I think one of the most interesting questions, is not why did Paleo-Indians begin to flute or why did they stem, but it could be why were microblades lost? Like what role did that form in these societies that was seen as not useful anymore, regardless of the routes that were taken? I find that, I don't know the answer to that, but I think that could be probative to think about. And maybe the loss of microblades in Japan, we can think about in the same way. I know in like the Ocean Bay tradition in southern Alaska, when we see microblades go away, they tend to be replaced by big slate bayonets. And so that might be an idea for what they might have served as prior to that. So it might be interesting to, in each of our regions to be thinking about the position that kind of technology played and then maybe ceased to be as useful. later on.
Just to put it in perspective, the Ubetsu technique, all the microblade technologies are unusually complex for lithic technologies. There are a lot of production steps involved. But nevertheless, we're probably still talking about 1% of the material culture of these people. If you look at the monographs, for instance, Cornelius Osgood's very detailed monographs of the material culture of people like the Deghetan. They used to be called the Incalic, but Deghetan is the correct term for them. I once went through that and calculated the percentage of preservable materials that we would find in the archaeological record from these people, and it was about 1%. Virtually all the rest of the material culture would be gone. All of the complex artifacts, the fish traps and the the small mammal snares, all of it would, none of it would be visible. But that's as we get into these northern environments where people are confronting these challenges of extreme winter temperatures and scarce resources and need to be exploiting this wide variety of vertebrates. That's where the technology becomes so complex and where the challenge of designing all this stuff becomes so formidable.
I think to play into maybe one of Dan's points later, this when we compare like even harpoons at lower latitudes versus harpoons in higher latitudes, they just radically increase the steps and complexity. And I wonder, just going the opposite direction, that all of this over-engineered, Arctic survival kit, as you move into the lower 48, south of the ice, maybe those pressures are removed. You have less of that pressure. And maybe with the high quality lithic sources that people then identify, you can be maybe more risk prone, or maybe trying new things, and that maybe could explain the variety of point styles that it seems like we're getting pre-Clovis, because I think we're all agreed they're highly variable. There's lots of different kinds in a short span of time. Mike, what do you have thoughts on what might be driving this variation? Because it's kind of counterintuitive. We may expect with a colonizing population it should be widely shared, homogeneous material, but it seems like it's not quite like that with the early pre-Clovis sites.
Is that on? Oh, okay. I think I have to agree with what Dan said, in that I think I've learned that you shouldn't have expectations of what you're going to find. You should find what you find and then try to figure out what's going on. Because it seems like all these pre-Clovis assemblages are really different, and but there is some commonality with the stem material in some places. But I mean, something like Manus was a real surprise to me when we had that plano-convex cross section and what we got, because and you're talking about preservation, that wouldn't preserve except for it got stuck in the rib of a mastodon because he's probably going for the lungs and the animal moved. And how many of those have been lost in paleontological excavations and even archaeological excavations and not even seen because our expectations are such. And it may be that these people were coming in with different toolkits, and after they got settled in, then you might see a kind of maybe this Clovis phenomenon go through that population.
Yeah, so I think I look at it in the context of expectations in terms of predictions. Like if our hypothesis is correct, we'd expect these sort of patterns. And what I think we're seeing, if we compare like ASTT, which is clearly demographically an expansion of Eskimo Aleut populations, Paleo-Siberian groups across the far north, we can see it's instantaneous. We can see this the material culture is identical from Greenland, Alaska, and Thule, the same thing. So it strikes me anthropologically interesting that here we have another movement of people into uncolonized areas that's different. That to me is this ambiguity that's really interesting. So maybe when we think about models in the future, that might play into maybe a star-like radiation could be lineages that diverge quickly and don't communicate immediately. And so these sort of founders effect kind of a thing. sorry for the analogy, may be impacting the lithics.
Ben bringing up the ASTT had me think about something in relation to John's idea of design and risk. And, if you think about the colonization of the Canadian Arctic and Greenland by Arctic small tool people, they arrived maybe 4,500 years ago, and they're in place for 3,500 years, with a gradual evolution from early to late to Dorset. The contrast between Dorset and Thule is just so glaring. Dorset, very conservative, relatively few tool forms. They're pretty much the same wherever you go, and they're occupying a much narrower niche, and they are almost instantaneously replaced by the Thule, who are very flexible. I think Mathiasen described them as gadget infested, maybe 1,000 different organic tools. And that is I think a much more flexible, risk-taking approach to life than the Dorset. The Dorset were so conservative about everything, and that they were in the same environment, occupying the same sites, but doing it very differently.
And one other point, this started to take it more towards the Arctic, but it reminds me of a counterintuitive result we find where the ASTT populations did encounter Northern Archaic peoples, and they replaced Northern Archaic, or at least Northern Archaic peoples still continue to persist in the interior. But it's interesting, ASTT did not borrow technology. Even though we know they're in the same place, they're interacting, similar sites, sometimes the same site, like Onion Portage. It's interesting that one thing we often don't think about is the culture of the people might be averse to borrowing, or might be prone to borrowing from other societies. And so, it's very difficult from the lithics alone to really make sense. And for me, at least, the faunal record is so critically important to understand how they're adapting on the landscape. And so a lot of the work that I tried to present was, what was the life way like? What were the economic strategies that people had sort of through time, and where did they do these strategies in the context of mobility? So I'm hoping tomorrow we can hear, more on the Japanese side for how the coastal adaptations occurred, when, in what context, what did we see technological changes too? I'm very curious with what we're seeing with possible connections with Beringia, North America, and Japan, some of these ideas. Do you guys have sort of thoughts on the data sets that we're talking about? Any thoughts on the Japanese side? Are there things that we should be looking at that were not, or that you didn't see presented?
Let me speak again in Japanese. I'd love you to look forward to tomorrow's session. That's what I want to say. Well, partially, I think we are able to present some of those data, as you mentioned. Well, rather than on our side, but I would like to learn more about non-Japanese things. One more question. In Dr. Hirasawa's presentation, Northeast Asia, strict U-baits, chronology seems to be settled. I think that was very fast dispersion. And that origin of place seems to be PSH or Korea, or anyway, northern part of Japan Sea. That's the idea. Then dispersion started. That's what explained. Then Dr. Potter asked a question to you. How strict UBITS idea was dispersed? That was the question. All the assumption, Dr. Kerry Grant, Dr. Ian Purvis, including myself, if our LGM and Siberia assumption that there is no people living in LGM, if that assumption is correct, then there's no people, then from Hokkaido, people might exit it from Hokkaido directly. That could be possible also. Then assumption here, it possible to correspond to the genetic analysis? If it's not, what is the barrier? If I can speak in Japanese, let me speak in Japanese. I don't know whether I'm confident enough or able enough to respond to your question. But in a specific group, what is the root that's not known, including the chronological order, well, Hokkaido or Korea could be older. Yes, that's possible. But the footprint afterwards, it's not known. So if nobody is living in the area, unmanned area, sometimes people can invade then. In Swan Point is 14,200 years ago, or the 18,000, 17,000 years ago was the UBITS emergence in Northeast Asia. Then perhaps span would be 3,000 years or so. Then what type of biological human population were there in terms of number, or each of those groups were isolated? We don't know yet. But anyway, ancient Beringian in the late Jomon population, not related, not connected, then we don't have that DNA data. So therefore, very difficult to make any relationship. If we could find some connection, then it's possible to make some of the argument. Unidentified population A, that's another branch, as I shown in the slides. Statistically different population should be in existence. If that population is related, then ancient Beringian or before ancient Beringian in the standstill model, then that type of population did exist and they played a driver for the dispersion. That's possible. Maybe I made a wrong way to ask. To Dr. Martin Sikora, I want to ask this question. Regardless of the origin place, 18,000 or 17,000 years ago, in Far East Russia or Lake Baikal, population might have expanded quite rapidly. So genetically speaking, from a genetic study, can you explain this? Do you think? Use microphone, please. And speak slowly, please.
I'm not entirely sure if I completely got the question. So you're asking that which of the populations that we have genetic data from around 18,000 to 17,000 at Lake Baikal area, what populations those could be, or how they would have expanded? Can you maybe slightly clarify the question?
Hi.
Yes, 18,000 to 17,000 years ago, between those, there's one assumption. From Lake Baikal to Far East Russia, the same genetic population could have been expanded rapidly. That is one assumption.
So we do have genetic data from, if you recall the sort of the map, the presentation. We have genetic data at the moment from three different individuals in that time period. Well, actually, it's more like two because we don't really have Kolyma River is quite a bit later. So we have the individual from Uskiatka, which is maybe at 15,000 years in Lake Baikal, and then from Kyrgyz Cave, which is at 18,000 before present, which both genetically are quite similar overall. So they both show this kind of very similar pattern of admixture between an ancient North Siberian and an East Asian group. So if that matches this kind of dispersal of these technologies and rapid expansion there. I mean, it could be that we're talking about sort of one larger group of people that were quite widely dispersed in that area or rapidly expanded up there. I think that could be, consistent with this type of model. I don't know if this answers your question.
Yes, that's what I exactly wanted to hear. Thank you.
私も日本語で。
Let me speak in Japanese. About 50 years ago, when I was a student, I studied abroad in Canada. There was a famous scholar said, Clovis, if 1,000 people got together, then they could have maintained their existence. That's what he said. But then, what size of people? In what way people migrated into Americas, little by little, or a certain critical mass required for the survival, a certain size at least, or one wave, two waves, three waves? In archaeology or in genomic research, could I get the opinions from you?
Sizes that have been estimated for FAM?
Hello? Yeah. So the question it's a little bit difficult to answer. What we can answer from a genetic side is what we observe in terms of the effective population size in those populations. So it's important to remember that this is not a measure of the actual number of people that are migrating, that are in the census population. It's just a measure of what is the sort of reproductive population in an idealistic scenario. What would be the minimum size for that? And what's clear is that there was a pretty strong bottleneck in the founding of the first Americas, one of the strongest ones we have observed in sort of human dispersals around the world. We had for the Yana side, which is not directly related to the first Americas, of course, but we did try to answer this question of, again, effective population sizes, what these early hunter-gatherers up there would have had, and we could see that there were certainly evidence for at least 1,000, maybe 2,000 reproductive individuals in that population. Again, this does not mean that the census at the Yana site was that size. It means that their ancestors were a reasonably large population, and maybe at that site there were only a couple of them. And the same is true for the first Americans. So I think I'm not entirely up to date with the latest estimates of what the sort of minimum number was. I don't know, maybe Ben, if you have a sort of a number for that.
I think it was a wide range of 200 to 2,000,
something like that. I mean, what we can say is that it really it's quite a strong bottleneck in terms of reduction of genetic diversity. But to what extent that correlates with an actual census population size, we can't really make that connection from the genetic data. In terms of what viable population size the census would have had to support a population, well, I think maybe some of my colleagues will have a better answer for that, because that's not something we can tell from genetics, really.
And I think it's far worse in archaeology to try to estimate populations based on lithic assemblages that are widely spaced, in time and space. But I think it maybe highlights something we should think about with this very unusual bottleneck in small population. Drift effects a founder's effect can be very strong in small populations. So if we have a population maybe with a late Upper Paleolithic toolkit, emerging into a very new area, we can imagine all sorts of possibilities with how that could be changed rapidly and in ways that aren't like a continuous flow, that we can track them. Because I think we can say that for sure, that there is no continuous flow from what we see in in Eurasia broadly to what we see in Beringia and America. They're really, really different. And since we know there's genetic connections, it must be something like an effect of just small populations that lots of things can happen, within small groups to cause very different material cultures. But I did, oh, go ahead, John.
Where is the bottleneck? Where does it occur? Is it in ancient Paleo-Siberians, or is it after the divergence of the ancient Native American group?
So that's a good question. Yeah, spatially, of course, we cannot, from genetic data, tell where it happened. We do see evidence for severe reduction in genetic diversity, both in the Native Americans, but also in Colima River. There it has quite long stretches of homozygosity, so that would certainly suggest that there was at least some amount of shared bottleneck between them. But then where that happened, whether it happened before or after the admixture already, to a certain extent before maybe, we don't really have an up-to-date answer for that, I think. But all these populations up there, both Paleo-Siberians and first Native Americans, do show evidence for quite, or at least from those individuals that we have genetic data from for quite a severe restriction in genetic diversity. But whether it's a shared bottleneck, it's like two independent bottlenecks of just generally small sizes of groups migrating there, I think there's still more work to be done to try to disentangle it.
I think maybe to address Masami's question, I think maybe the way I think about Dyuktai and maybe FAM relatedness is kind of going backwards. So Kolyma we know is Paleo-Siberian, and the dating of it strongly suggests this is Sumnagan. This is related to what looks to be a population replacement in far Northeast Asia. So it's possible, I guess, Dyuktai could have been an earlier Paleo-Siberian group that was replaced by another Paleo-Siberian group, but I think it makes more sense that Dyuktai was something else. And FAM would be the logical choice. It's moving forward at the right time. We can track it from 17,000 into 15 and then 14 into Beringia, and it's there in Alaska. So, but you're right to say it may be something else. There could be another correlation between the bearers of Dyuktai technology and their genetic relatedness to other folks. Are there any other questions? I think we could open it up to some questions from the floor. But we will have another opportunity tomorrow to have a 2-hour discussion, a longer discussion among us. But I know there were some questions. I think you had one.
I have a question to Dr. Odes and also perhaps Hoveka. And I was wondering if we accept a small number of groups migrate to the America earlier than we have traditionally expected, why they can be extinct? It's related to the former question, but it's kind of hard to imagine because as Dr. Hofecker suggested, if they already have advanced or complex technology to adapt to the north, so they were successful people in a sense, but why they couldn't be a successful migrant in the Americas? Do you have any idea?
I think that sorry. It's on. Okay. I think that there are any number of explanations. In small populations, it doesn't take too many bad accidents to really make things precarious for people. If you are dependent on the productivity of a very small number of individuals to feed the group, one or two of those individuals being injured while hunting or boating or whatever can really set things on a pretty precarious path. So just small group issues is one effect. I think also, you know, when we have groups that are isolated for long periods of time and then come into contact with people that they haven't had contact with, we should be mindful of the possibility of disease causing real disruptions. But of course, that's a very difficult thing to see. John?
Yeah, I was just going to say, small isolated populations tend to go extinct. We know that from ecology, population ecology. And if these people came through this ice-free corridor, say 28,000 years ago or whatever, and then it closed a few thousand years later, they might very well be a small isolated population.
And one other point, we actually, I think, do have some direct data on this. At Upward Sun River, we have a very small community, maybe on the order of 20 people that would be co-residing. And within probably a week or a couple of week period, 3 infants died, a neonate, a newborn, and a 3-year-old. That's a small population, and it's in, from what we can tell, the best season of the year to get the most resources. So summer has many more resources than any of the other seasons. So I think what that's telling us is that even in the best of times, infant mortality was probably high. And if you didn't have larger populations to sustain, possible extinctions could happen. Ancient Beringians, we don't have direct evidence they continued. And that was a group that spread from the Seward Peninsula, the far, western part of Alaska, all the way to the Yukon Territory in the ice-free corridor area. That's a huge stretch with many, many sites. And it seems like they were either replaced or absorbed by later people. So any other questions from the audience?
Oh, am I audible? Pardon me, I don't study archaeology, and I want to ask Dr. How do I read this? Saikara about the east and western structure. So, do you think that there's a possibility that the terrain plays a role to construct the structure? Sorry, I may have missed.
No, can you just repeat the last part? I didn't completely understand.
All right.
The east-west structure.
So I don't study archaeology, so I have no idea about this. But are there a possibility that the terrain plays a role to construct the east and western?
That the terrain plays a role, like the
Yeah.
landscape. Yeah, I mean, I think it's very likely that the geography plays a big role in that, and how people are constrained to move in these early dispersals. I think there should very much be a big factor in those kind of structures.
Thank you. And one more thing. Were the horse was used for dispersal at that time of period?
No, that is much later. That's only starting to appear in the Bronze Age in the steppe. So that's maybe 5,000 years ago. So it was not used then.
Understood. Thank you.
Dogs would be the only domesticated animal at that point, but we do think dogs were part of this process. We haven't talked about it yet, but there's some exciting new research on dog DNA, and it seems to match broadly the human DNA patterns for the peopling. Maybe one last question before we close out today.
So I would like to ask a question in Japanese, which is translated. So my question is addressed to Dr. Welka. So actually, I am involved in an ethnological study of Siberia, Chukchi. So design theory is a very inspiring theory and also idea. So Neanderthal and also Denisha are different. So difference between the two. So more than 100 parts are necessary for creating one garment. That is actually quite interesting. So in tundras, application is concerned, and I think about the Chandra. For example, Yana site was mentioned, hunter-gatherers and a lifestyle, wasn't it? Also, Kolima site is also in tundra, and Chukuji is actually in the northmost region. So actually, garment and clothes are very important indicator for thinking about the level of complexity. Can we use clothes? Also, when thinking about the material culture, is there anything which can be related to the modern ethnological study? If you can think about the one material, something, for example, hide is a process, and maybe tools are necessary for the processing of hide. Even today, there are various tools and devices. But is there anything which can be connecting, which can connect itself to the ancient and also times and tools? And so we like to think about the level of complexity, focusing on the devices and also tools.
The Anna River sites contain the earliest evidence for vessels, dishes. They're 33,000 years old. They're carved out of mammoth ivory, and they're decorated. And that's sort of indicative of the, first of all, the domestic nature of the sites, that they're long-term occupations. They're not short-term camps. They're filled with all sorts of different kinds of artifacts. There are many needles, eyed needles that were used for sewing at the sites, also decorated. So we can see, thanks to the frozen, the permafrost deposits, which have preserved all of this material, these artifacts that more often than not would not be preserved. We have some hint of the complexity of the technology of these people. Does that answer the question?
Thank you very much. In Yana, there is bees and made of mammoths and bones. So actually, bees are related to the level of complexity. For example, those bees are used for the necklaces and for women. Do you think that can be used for the elucidation of the complexity of those tools and also technology?
Question, I'm sorry.
I think he was asking about beads. And I think, just maybe to close out this session, art among these very early peoples, it's very rare to get it, but we do have bits of it in various sites. We've got some that I've excavated at Mead. Of course, the Yana site is just out of this world with various art objects and decorated objects. One interesting thing, the most common form tends to be beads. So the idea of body ornamentation in a highly mobile society. There are some ideas out there from Mary Steiner and others that they form communication networks among people that may not be speaking the same language, but maybe share different ideas and values related to beads. Interesting to think about. So thank you for your question.
Thank you very much for your answers. Thank you.
Today, and then let's meet again tomorrow. Okay, thank you so much for all speakers. Thank you, audience.